interest in cover cropping systems. I just wanted to check how many people here, I recognize some faces, came to the economic cover crop talk yesterday. Okay, so you'll recognize a few of the slides I go over, but it's looking at it a little differently, and I think there'll be some more information, and if you were sleeping yesterday, you have another shot at it. So, yeah, we're looking at capturing nutrients with cover crops. So mainly I'll be talking about nitrogen. That's what I've been working on, but I'll go into a little bit sulfur and phosphorus at the end. All right, so we started noticing this pattern across the landscape, driving across near farmland, and this is in late fall. And you can notice the green stripes going across the field. And when we started thinking about this and looking at this, they're spaced every 60 inches. And we realized this is leftover nitrogen that was side dressed every other row the previous June that wasn't being taken up by the corn crop. So this is leftover nitrogen that the rye is scavenging, and we're seeing these patterns across the landscape. So here's another example. That's the last field was rye. This is a radish field, and you can see there's same light green, dark green stripes across the field, and that's on every 60-inch center. So every 60 inches we're seeing this. So that got us thinking, how much nitrogen is left after growing row crops? How much is the crop taking up, and how much is left in the soil that's available for a cover crop? So we decided to look at that. So we took soil cores on different farms, and we looked at all of these farms. We tried to include different regions, the coastal plains and sandy parent materials, and into the Piedmont of Maryland and some residual parent materials, and then up a little bit into Pennsylvania and Lancaster and York County up there. And at each of these sites, we took deep soil cores in a transect across the field. So we were looking at the soil from the surface down to 7 feet deep. So we were taking 7-foot deep soil cores in a transect. So that's kind of our sampling pattern. If that's a field, we would draw an imaginary line and go about every 50 or 100 feet going down the slope of that field and take a set of these deep soil cores. And then we were measuring the amount of nitrogen in that soil in each layer going down. So we found a lot of nitrogen is left in the soil after growing corn and soybeans. Probably building up. Some of it's building up every year. Some of it is new nitrogen that's mineralizing or being applied in the form of fertilizer. So on average, this was the 29 sites that we looked at, and you can see they can be highly variable. But on average, we were finding 226 pounds per acre of mineral nitrogen from the surface down to 7 feet deep. And 100 pounds of that was nitrate, and about 120 was ammonium. So we think the nitrate is leaching down pretty quickly and goes several feet in a year. But the ammonium is probably more from previous years kind of building up over time, because that's being held onto the soil through cation exchange. And we're finding, so it's variable. On some farms you have only about 100. The light blue bars here show the nitrate, and the dark blues show the ammonium. So if you add them up, you get about 100, versus some farms are up around 500 pounds of nitrogen that is left in the soil after growing corn or beans. Feel free to ask any questions if some come up during the talk. So just looking at that data a little bit more, we were comparing the residual parent material soils to the coastal plain soils. So here we have the surface down to 7 feet. So each foot layer from the surface going down. And we found about half of the nitrogen was in these lower soil layers. So about half of it is in the top meter, and about half of it's in the bottom meter. So maybe 100 pounds in the top and 100 in the bottom. And the differences between residual and coastal plain soils was that in the deeper layers, we're finding less nitrate. So this graph over here shows the nitrate, and this one over here shows the ammonium, the levels of ammonium in the soil. And for the nitrate, we're finding less nitrate in the coastal plain soils. And of course, the coastal plain soils are more leachable, so we think that nitrate is just leaching out of the soil, whereas the ammonium is, there was no significant differences between those different soil types. So then we got to wondering about the difference between corn and soybean. So is there only a large pool of nitrogen following corn because we're fertilizing the corn, or is it also an issue after legumes when you're not fertilizing them? So the data that we had taken on those 29 farms, some of it was soybean, but they weren't side-by-side fields or anything. So this past year, we decided to look on the same farm. We looked at 4 farms, and they had side-by-side fields of corn and beans. And we took transects of soil cores in the corn field and in the soybean field to compare. And we actually found more nitrate following soybean than following corn. So that was kind of surprising, but kind of not, because the soybean, of course, is fixing nitrogen and mineralizing nitrogen, and it's a low carbon to nitrogen ratio. So we have all of this available nitrogen following soybean, and especially on nitrate. So this graph is showing nitrate from the surface down to the 7 feet, and in those deeper layers, we have more nitrate in the soybean, following soybean, than following corn. And that's going to be important later when I talk about management, because next I'm going to get into some of the cover crop systems we're looking at that can capture some of that and scavenge some of that leftover nitrogen. And it's particularly hard to get a good early planted cover crop in after beans because it's harvested so late. So just keep that in mind. We think that it is really important, and I'll be going over some management implications at the end and ways to get a cover crop planted early into a bean field. So of course, this pool of nitrogen we're finding that remains after growing corn and beans in the deep soil layers, of course, that's a risk to leach into the groundwater over the winter months. So you have 8 months out of the year where there's no crop taking up nutrients until when you would plant the following row crop. And all that time, the nitrogen is going to be leaching into lower soil depths. So that's where our cover crop work comes in. So this is the sign that we're putting up on some of our collaborating farms, and kind of our motto is deep-rooted cover crops, adding nutrients to your bottom line, not to the bay. So the idea is that we can kind of kill 2 birds with 1 stone. We can reduce the amount of nitrogen leaching out into the groundwater and out into our waterways, and at the same time, if we can capture and recycle this nitrogen, then we could reduce the amount of fertilizer that you need on the following crop and could have some cost savings for the grower. So our hypothesis was that if we can get an early planted cover crop in, and often that's when the corn is still, or the beans are still standing in the field, if we can get that early planted cover crop in, it can grow deep roots, capture this pool of nitrogen, which some of it's in that top meter, but about half of it is in the lower meter. And don't forget, the lower the nitrogen is, the more likely that nitrogen is going to leach out of the system. So the lower nitrogen is really important to capture if we're going to keep it in the system. It can capture that nitrogen, bring it back up into the biomass of the cover crop, and then certain species, such as brassicas or clovers, they will decompose pretty quickly in the spring, and our idea is that they will then release the nitrogen on the soil surface, and now you have nitrogen at the right place and the right time to be used by the following corn crop. So that was our idea, what we were going to investigate. So here I just wanted to show you a few pictures comparing an early planted cover crop to a late planted cover crop to kind of just illustrate the difference between these two. So this picture up here is a mix. This was Lancaster County, a mix of radish, triticale, and crimson clover. And it was planted on September 2nd. And we had some other cover crop treatments on that farm, a straight triticale and a straight radish. And all of the cover crops that were planted by September 2nd on that farm, they took up between 130 and 180 pounds of nitrogen. in their biomass. You can see how productive they were. And then just contrast that this farm was planted on October 5th, and that one only took up 4 to 7 pounds per acre of nitrogen. So just a huge difference. Yes, sure.
Can you just briefly touch on the history between the two fields?
Yeah, so these are not direct comparisons. So this one is more a sandy soil field in kind of the western shore of Maryland, and then this one was up in a heavy manure history. They both actually did have manure applied, but he had a horse farm on his land, so that one had horse manure applied. But the next photo I show will be more of a direct comparison. But I just wanted to point out the magnitude of difference between the nitrogen. But this photo, these were actually right next to each other, side-by-side plots a few feet away. And there's a radish here planted on August 28th. And then that's actually a radish in my hand there, that little tiny thing, planted on October 1st. And they were only a few feet apart at one of our sites. Now I'm going to go into some of our on-farm trials. So we've been setting up trials, working with farmers across the region in Maryland and up into southern PA. This farm was from Lancaster, PA, where typically, a lot of times our plots are bigger than the one shown here. Sometimes it'll be a whole strip across the field. But on all of the farms, we're looking at 4 different treatments. We have a pure radish stand, a pure winter cereal stand, and we let the farmer decide what to plant on that winter cereal. So often it'll be rye or triticale or wheat, and a couple farmers did oats. And then we have a mix, and in the mix we ask them to do a radish, some kind of winter cereal, and a legume. And for the most part they all did crimson clover. So we had those 3 species combined into a mix. And then we always had a no-cover crop control. So this is one of those trials in Lancaster, PA, planted on September 2nd, and that farm had a history of heavy manure application. And the trials, we sampled the biomass, and then we measured the percent of nitrogen in that biomass. And we also took deep soil cores in each of the plots, and we used these Viehmeyer probes. So basically, we just hand drive them into the ground with a drop hammer, and we always go down to 7 feet. Occasionally we hit rock or something. We can't get that far, but we try. Okay. So here's the biomass results from that farm in Lancaster County. And on the y-axis is the nitrogen uptake. So that's, we weighed the dry matter of the cover crops, and we multiplied that by the percent of nitrogen that was in that plant material. So the cover crops in November on that farm took up between 130 and 180 pounds of nitrogen per acre. And then we went back in the spring and measured how much growth and nitrogen uptake by those same cover crops in the spring. And here we can see that the triticale continued to grow and take up more nitrogen into the spring. So it was at about 130 in the fall, and it went up about 50 pounds to 180 in the spring. The mix now has less cover crop biomass and nitrogen uptake in the spring, and that's because the radish in that mix winter killed. So now all that radish biomass is decomposing. And then here we have the control, and what we found on this farm and a lot of farms is without a cover crop, we're getting a lot of winter annual weeds that are a lot of biomass in the spring for the control. And so I just threw in this picture to show you what that looked like. So this was the control plot, and you can see all those weeds that came up. This photo was taken in April, and then that's where the radish was. And we didn't spray herbicide or anything. That's just what the bed looks like after radish. And we see that over and over again on the farm sites. When you have really productive radish, it just wipes the weeds out. So here's some graphs showing what the soil looked like under those different cover crops. So I'm going to show a few of these graphs. And the top of the y-axis here is the surface of the soil going down to 210 centimeters. So we're looking at the top foot, and then 1 to 2 feet deep, all the way down to 7 feet deep. And then this is the nitrate, the pounds of nitrate that we found in each of those soil layers going down the profile. So these are the soil cores that we took in November, and down at the bottom, these are the soil cores that we took in April. So the black line here is the control plot where we had no cover crop. And you can see a big bulge of nitrogen on the soil surface in November where there was no cover crop growing. So we have about 140 pounds of nitrogen in just the top foot in November where there was no cover crop. And then you can compare that to all of the cover crop treatments. So it didn't matter whether it was radish or triticale or the mix, all of the cover crop treatments were scavenging this nitrogen, taking up this nitrogen in the fall. So we saw the difference in the amount of nitrate in the soil all the way down to 180 centimeters deep. So all the way down to 6 feet, we could find evidence that the cover crops are scavenging this nitrogen in comparison to the control that had more nitrate. And then when we look at April, now if you look again at that black line, which is the control, you can see where there was this pool of nitrate on the soil surface in November. Now that's moved down to 60 to 180 centimeters. So now that's leached down between November and April down about a meter, and that nitrate is now all the way down a meter deep, which is probably most likely out of reach to anything that you're going to plant after that. So all that nitrate is being leached away. And you can compare that to the triticale. Now the triticale is still holding on to the nitrogen. So there's very little nitrate in the soil under where the triticale is growing. So that's doing a good job of holding on to that nitrogen. And the radish here is interesting. So the radish has released, so in the fall, it had very little nitrate. But by April, it has released a pool of nitrate on the soil surface. The radish decomposes very quickly and leaches out that nitrogen in the form of nitrate we found mostly in that plant available nitrate. So you have this pool of nitrate on the soil surface where the radish was growing. I'm going to show another 2 trials that we did in Maryland. So now we're looking at more sandy parent material soils, whereas the last one was up in the Piedmont in Pennsylvania. So here, even though the cover crops were planted, this one was planted by late August, and here was planted by September 11th, we have less overall biomass than in that Lancaster field with the history of manure, but we still have significant uptake of nitrogen by these cover crops. So these photos show the wheat and the radish from this farm over here in Dorchester County, Maryland, and the radish took up about 80 pounds of nitrogen per acre. The mix was about 60, and the wheat in this case was about 25 pounds of nitrogen per acre. And then in the Kent County farm, we're looking at between about 15 and 40 pounds of nitrogen that were taken up by those cover crops. They were planted a little bit later. I wanted to point out at that farm we had a cover crop planted on September 11th, the mix, and then we planted a later mix. So we looked at a mix planted 2 weeks later. So the later you plant the mix, the less nitrogen it's going to be taking up is the main takeaway with that. And then here's the soil profiles under where we had those cover crops in Dorchester County. So that's, we took soil cores in that field at these plots here in this field. And we see similar patterns to what we saw up in Lancaster County. So again, you have the control, which is the black line, and you have, these are taken in the spring. So in the spring, you have a pool of nitrate in the control on the surface, but also down in these deeper layers. So down to 120 centimeters, you have this pool of nitrate that you don't see where you had cover crops. If you look at the different cover crop treatments, you see similar patterns. So the rye and the mix, which is the orange and the purple lines, those are holding on to the nitrogen, and the nitrate is lower, all the way down to 120 centimeters. And here you have the radish, which, like in the other case, released the nitrogen by the spring. So you have this bulge of nitrogen on the soil surface up here in the spring, under where the radishes are. And here, similar findings at a different farm up in Lancaster, PA. So I won't repeat everything again, but we have this bulge on the surface from the radish. The control has higher levels of nitrate down where we don't want it in the soil profile. And then really what I wanted to point out here was these two mixed treatments. So we're kind of thinking that the mix can give you the advantages of both of the species in that. So here we see that the mix is holding on to the nitrate in the deeper soil layers, which is what we wanted to do, and scavenging that nitrate, but it's releasing some nitrate right on the surface, so from 0 to 30 centimeters. Whereas the radish may be releasing too much too early. That mixed treatments, sometimes they can release just the right amount where we want it. So ideally, we'll have the nitrogen scavenged from the deeper layers, but a small pool then released on the surface for the corn to take up. So then we could apply less nitrogen fertilizer to that corn. So that's what we're seeing here. And the early mix is that purple line, and the late mix is the pink line there. So I think there's a lot of potential in those mixes. Yeah?
Are you saying that it's possible there's a situation with the mix maybe more of a floral leaf instead of just a flush like the soybean?
Yeah, I think so. Mm-hmm.
Would the cereal grain be available later in the season versus just spring?
So I'll show some slides of the following corn, and it doesn't seem to be available for that year's corn. Maybe, eventually it should be mineralizing and become available maybe years down the line, but we're seeing lower corn yields following that. So not by that summer, it doesn't seem to be. Okay, so the next study I'm going to talk about, we were really trying to understand better what exactly is happening with this nitrogen scavenging of the cover crops. What species are doing this best? What is the critical planting date that we have to plant these cover crops by? And how deep are they going for each of these different planting dates? So in order to do that, we use something called nitrogen 15, which is basically just a heavy version of nitrogen. It's found in very trace amounts naturally in the environment, and people concentrate it, and they put it in little bottles, and they sell it for like $50 a gram. And then we can bury this nitrogen, and it serves as a tracer. So we can follow the nitrogen, how it moves up into the plants or how it moves down in the soil, and we can plant cover crops on top of where we buried the nitrogen. And then if we find that heavy nitrogen in the cover crop biomass, we know that the roots got down to where we had buried it. So then that gives us a way to know how deep the roots are actually going. So we buried the nitrogen at either 60 centimeters, 120 centimeters, or 180 centimeters deep. And then on top of where we backfilled the hole, and we included a bentonite mix so it would expand and the roots wouldn't just be preferentially going right down where we had buried. And then we planted the cover crop on top of that. And each of these little flags here is where we had a point of that heavy nitrogen buried. And we looked at two different planting dates, September 3rd and October 8th, and we looked at different cover crop species. So the radish by itself, a rye, a two-way mix of radish and rye, and a three-way mix of radish, rye, and crimson clover. And we wanted to look at the mix with and without clover, which is a legume, because we were wondering if the clover, which is fixing nitrogen, is going to affect the ability of that radish and rye to scavenge deep soil nitrogen. So if there's, and we thought of that because the cover crop program in Maryland, until recently, they didn't allow you to have a legume in the mix. So and the idea behind that was that the cover crop is supposed to be picking up nitrogen, and we don't want to have a species that's going to be added to the system. But we were just kind of curious, like, is that really true? the radish and rye pick up less nitrogen if there is a clover in the mix. So that's why we had those two treatments. So we took biomass samples of our cover crop in November and again in April, and then we could send those samples off to a lab and get them tested to see if they contained that nitrogen-15. And if they contained it, then we knew that the roots got down to where we had buried it. So this is what we found. So the y-axis here shows the amount of nitrogen-15 above the level that we would expect everywhere in the environment. And then we have the different cover crops here. And we found that the radish and the rye and the radish within the three-way mix, they were all able to capture that nitrogen from 60 centimeters deep. And they got it whether they were planted early or whether they were planted late. So both of those species were able to capture nitrogen-15 from 60 centimeters deep, regardless of the date. And then when we looked at we compared the two-way mix without the clover to the three-way mix with the clover, we saw that the clover is really having no effect on the other species in the mix. So here we have the same axis here, the percent of nitrogen-15 in that sample, and we have the top of the radish and the tuber part of the radish and the rye. And the blue bars is the two-way mix without the clover, and the orange bars is the three-way mix with the clover. And there wasn't any difference in those, the radish or the rye, in their ability to take up or to capture that nitrogen-15, depending on whether there's a clover or not. So the clover was not impeding their ability to scavenge nitrogen. And this is the scavenging from 60 centimeters deep, and over here is from 120 centimeters deep. So they're still going down to 120 centimeters deep, whether or not there's clover in that mix. And here, this is showing some of our results of the different burial depths. So over here, which is what we just talked about, when we buried that tracer at 60 centimeters deep, the cover crops were able to pick that up whether they were planted on September 1st or October 1st. When we buried the tracer at 120 centimeters deep, now only the September 1st planted cover crops are picking that up. So we did not find any of that tracer in the October planted cover crops. So they don't seem to be able to get down to 120 centimeters. And then over here, we saw that for the early planted radish, we picked up very small amounts of tracer from 180 centimeters deep. So it was pretty impressive to us, and we were excited to find that the radish, these samples are all being taken in November. So between when we planted it on September 1st, or I'm sorry, the samples were taken in December, and we sampled it in December. And those 3 months, that radish was growing roots down 180 centimeters deep and getting that tracer that we put down there. So then we wanted to know if a cover crop is planted later in the fall, it's not planted early, and you let it grow longer into the spring, we'll be able to capture and scavenge that nitrogen in the spring that it missed in the fall. So there might be an opportunity in the spring to pick up some of that nitrogen. So we sampled the cover crops again in the spring to see if they were able to get to that nitrogen that we buried at 120 centimeters deep. So here we saw that really they're not. So the October planted cover crops were not able to get the nitrogen in the fall, and they were still not able to get the nitrogen in the spring. So what we think is happening is that the nitrogen, the cover crops are growing deeper roots in the spring, but the nitrate is also leaching down the profile. So you have all of these winter months where it's raining and there's nothing, and the roots aren't growing during the winter, and all that time the nitrate is leaching lower and lower in the profile. So if the roots get that far down in the fall, and the nitrate's still leaching all winter, the roots are growing more in the spring, but they're just not able to catch that nitrate that's also leaching down through the profile. Now I'm going to show a few slides of some work that we've been looking at the nitrate in the groundwater under different cover crop systems compared to a no cover crop system. So this was done on Kent County, Maryland, And here we have the macro pore water nitrate concentration taken from 90 centimeters deep using lysimeters. So this is showing the samples that we took. The yellow bars, we took samples in February. The green bars were from late February, and then the blue was from early April. And here we had the same treatments. We had a cereal rye, a mix planted early, and all of these treatments were planted on September 11th, except for the late mix, which was 2 weeks later, in later September. And then the radish and the no cover crop control. So really all of the cover crop species had much lower amounts of nitrate in that pore water all the way through the winter and the spring than the no cover crop control. You can see the difference. So this is nitrate, so about 45 parts per million is the EPA drinking water standard. So the no cover is getting up there. All of the cover crops are really doing a good job of cleaning up that pore water nitrate and the groundwater nitrate. Oh, and another thing that I wanted to point out here is that a lot of times people are concerned about the radish because it releases the nitrate so early in the spring, whether that will then leach down in the spring and still cause the nitrogen leaching. And for the most part, we're finding that that's not happening. And that's what you see here. Even though this was a sandy soil and we expect nitrate to be leaching, the radish is still keeping that nitrate out of the pore water in April. Here's another similar study, except this time our cover crop was all the same mixed species. So we were looking at triticale radish clover mix for the cover crop, and we were comparing different planting dates. So we were looking at the pore water nitrate concentration, again at 90 centimeters deep, for the control, which is this green line up at the top, versus all these different cover crop planting dates. And we found that the control has higher nitrate in the pore water, and way down here is the EPA water standard, so much higher than we would want to see in the pore water. And then as we get to earlier and earlier planting dates, it's cleaning up the nitrate better and better. So this, the next line down, this blue is planted in late September. So it has lower nitrate concentration in the pore water than the control without a cover crop. So it's better than nothing, but it's not cleaning up the groundwater the same as those earlier planted cover crops are doing. So next I'm going to talk about the effect of these different cover crops on the following corn yield. So we were wondering whether the nitrogen is going to be released for the following corn or be immobilized. And we're really interested in trying to investigate these systems that would capture and release the nitrogen to allow the farmer to apply less fertilizer for the following corn. So here's just a couple pictures. This is the corn after, this is from the same field, different cover crop treatments, and the same guy standing there. This was the corn after growing rye, after no cover crop, and after radish. So you can visually see the difference in the corn. There was no starter nitrogen applied on this corn. So, and then here's just another example of this difference in the availability of nitrogen for the corn without starter fertilizer. And we know that's not realistic to not apply starter, but we just wanted to point out the difference in the amount of nitrogen available for that early corn. So it could be realistic if you're following corn with radish. Yes?
When was the rye terminated?
In this one, I know that it was terminated right before the corn was planted.
What date do you have?
I'm guessing early, like late April. Yeah. So then here's the results for the corn yield. And here we see that these same patterns, we actually took measurements at the V5 stage, and we were finding that the following rye cover crop, we had smaller plants than following the control, and the following radish had the highest amount of weight in the V5 stage. But then here in the corn yield data, we were finding the same pattern. So still the radish is having a higher yield. And we looked at a nitrogen response curve. So we had the farmers apply 0 fertilizer, half of the amount that they normally would apply, and then their normal amount. So in this case, he normally applied 120 pounds per acre, and then 1.5 times. So we're kind of looking at the cover crop effects across these nitrogen fertilizer rates. And the radish had the highest yield. The mixed cover crop, which is the blue line here, had yield similar to not growing a cover crop at all. And for the winter cereal, in this case triticale, we had a yield hit all the way to 1.5 times the amount of fertilizer that they would normally apply. And we saw these similar patterns at another farm in Lancaster. And I want to point out that we're not implying that after rye you're always going to get a yield hit, because we didn't have any starter nitrogen applied on these farms. So with starter nitrogen, you're likely not going to see the yield hits that we're seeing here. But we are saying that either you have to apply more nitrogen to the corn, or you're going to take a yield hit after rye compared to some of these other cover crop treatments. Yeah.
I'm sorry, what was
Sure.
the stage of growth? How tall was the rye, and how far ahead of the corn was the rye terminated?
So this data here was that same farm that showed the pictures of the 3. So this was terminated. This was not sure if it was headed up, but it was pretty big rye in the spring. Mm-hmm. Yeah.
How long was it dead? How far in advance of the corn crop did you terminate it?
I think it was about a week ahead. Yeah.
But I mean, at some point, the plant's going to still have it's not going to start to decompose a week later, so yeah, all that nitrogen
Right.
would still be.
Right. Yeah, so so if rye is terminated earlier on in the season, yeah, we're seeing that has a much lower carbon to nitrogen ratio. But if people are trying to get the rye to be scavenging the nutrients and pulling up the nutrients, then it tends to be immobilizing, and if it's growing later, yeah.
What about the allelopathic effect that comes with the rye?
Yeah, that's another issue too. So we think part of the yield hit is from the allelopathic effect, and we think most of it's from the nitrogen, but that's definitely documented in the literature, that allelopathic effects. Yeah. So in terms of other nutrients, I have much less slides on these. I've been doing most of my work on nitrogen, but we have a little bit of data on sulfur and on phosphorus following the different cover crop systems. So here we can see this is the amount of sulfate sulfur in the top layer of soil, so about the top foot of soil, for different dates starting in February through late May following these different cover crop treatments. So the radish had the highest levels of sulfur in the spring. The oat and the radish was next, and then this brown line down here is the control, which was similar to the oat. So we find that the mixes and the radish are also scavenging that sulfur, and we're finding similar patterns for phosphorus as well. So this is the levels of phosphorus right around a radish tuber. So that's supposed to be a radish tuber, and that's supposed to be the hole left by the radish tuber. And these samples were taken in the spring, and we're finding this concentration of phosphorus right around that tuber, that the tuber is, root of the radish is scavenging that phosphorus as well, and then releasing it right around that tuber. And then this is the phosphorus soil data. So this shows the soil from the surface down to 125 centimeters, and all of these green lines here are different brassicas, so a radish and a rapeseed. And then the blue line here is a cereal rye, and the red is the control. So we see that the radish and the other brassicas are scavenging that phosphorus and then releasing it on the soil surface. So now I'm going to talk a little bit about management techniques to try to take advantage of some of these nutrients that are being scavenged by the cover crops. So first I'm going to talk about ways to get cover crops planted early so that they can perform some of this nitrogen and other nutrient scavenging. And then I'm going to go into some other ways to plant cover crops. So opportunities for planting cover crops earlier. There's a good window after corn silage or some other early planted crops such as potatoes. They can also be planted after a short season corn variety. So some farmers have been finding it economical to take one field each year and plant it into a short season corn variety, get a really robust cover crop growing on that field to scavenge these nutrients, and then they get a premium for that early corn on that field, even though it may be a little bit less productive than the full season. Or in July after planting wheat. So another farmer said that was economical for him. He would rotate his fields through and just skip a double crop of beans on one field each year and put it into a cover crop instead. But then there's some other techniques to get them into grain crops such as aerial seeding. And that has been pretty successful in Maryland. A lot of it depends on rain. If you don't get a rain, then you get a really spotty crop. And so if the grower has the equipment to irrigate, we found that it will definitely pay off to run the pivot around once and get that seed to soil contact and get the seed watered. And we did a trial looking at the cover crop flown on in early September versus drilled after the corn was harvested. And then for the flown cover crop, we had irrigated and non-irrigated. And really that combination of flying the cover crop on and irrigating produced a lot more growth in that cover crop than flying it on and not irrigating or drilling. You didn't really get that advantage of flying it on compared to drilling unless it was irrigated that year. And a lot of that just depends on whether you get rain or not. And then some species seem to do better flown on than others. So this was a barley that he flew on, and that the yellow here is weeds, so that was actually mostly weeds and only a little bit of barley. So some other techniques, you could plant a cover crop using a highboy, either in a corn or a bean. And this picture I found just by Googling highboy in Maryland. I was actually looking to see if you could rent one in Maryland, which I don't think you can. But this was from the 1960s in Maryland, somebody planting a cover crop on a highboy through a cornfield. So people have been doing this for a while in Maryland. And then there's some other equipment, like this is an interseeded developed by some folks up at Penn State, and they will interseed the cover crop at the V5 stage, and at the same time they can side dress the nitrogen fertilizer, and they can also apply herbicide, so they can do multiple things that one pass through the field. And they've been finding that under the corn canopy, usually enough light gets through to have the cover crop take. And then as soon as that corn is harvested, it will really take off. The soybean has been kind of hit or miss because it has a darker light under there. Yeah.
More to your last point about the soybean, the full season beans wasn't particularly having trouble with. The double crop beans not as much, does the canopy close much bean later, of course. So.
Okay, yeah, that's a good point. So then there's this other idea of precision cover cropping. So this is the idea of, you know that your cover crops are scavenging these nutrients, and what if we could get those nutrients right where we want them, right where the following corn crop is going to be, for example. So some people are trying to do this zoning of cover crops, and I'll show you just a few pictures of examples of some people that have been doing that. So this one was in a vegetable grower's field. So they put the cover crop of radish right where their beds were going to be, and then you're left with, well, first of all, you have the weed-free bed. You have a really nice broken up soil by the bio-drilling of that radish, and you have all that nitrogen scavenging and other nutrients have been scavenged. So you have a fertile soil there, so a good place to put the vegetables. And then in the wheel tracks, they planted rye. So then you have a rye windbreak and a place for the wheels. Here's some other techniques. So this is alternate drill rows of Sudex and radish, and up here is alternate rows of rye and radish. So you can have the growers who planted this, they taped up every other hole on their drill so they would only come out, so the rye would only come out every other row, and then in the small seed box they put the radish. So then they're able to get these rows, alternating rows of radish and rye. And this farm was actually from out in Illinois, but they planted the radish right in the row where the corn would be, and then in between that they drilled rye. So here you have the radish, the nitrogen's being scavenged and released right where you're going to grow the corn. So right at the right place and at the right time, and then in between you can grow the cereal rye. So that has other benefits. And I'm sure other people can get creative and come up with other good techniques as well. So just thinking about the species and what you want that species to do, where you want the nutrients, and getting creative with the equipment, I think there's a whole lot of potential and possibilities for ways you could get those cover crops to release the nutrients and capture them and put them where you want them. So that's all I have. I think we have a few minutes for questions.
Any questions for our speaker?
Yeah, sure.
Sarah.